Good afternoon. In the content of unit second, courtesies and skewness. Before the topic, we have already discussed theory as well as practical problem. Now we discuss a practical problem based on courtesies and skewness. So first problem. The first four moments of a distribution about the value 4 of the variables are minus 1.5, 17, minus 30 and 108. Find the central moment. Central moment means moment about mean. Mean, standard deviation, beta 1 and beta 2. These are the coefficient, Pearson's coefficient, beta 1 and beta 2 and courtesies. Okay. So we need here moments. So this is also problem covered moments. First four moments are given about the value 4. So according to our formula, any mean about point any, A is here 4. And first four moments, so these are mu1 dash, this is minus 1.5 and mu2 dash, this is 17 and mu3 dash equal to minus 30 and mu4 dash, this is 108. These first four moments about the value 4 are given and we have to determine first central moment, that is moments about the mean. So by the relation between central moment and moments about any points, we have mu1. Mu1 this is always equal to 0. That is first central moment is always equal to 0. Mu2, second central moment equal to mu2 dash minus mu1 dash square. Mu2 dash that is 17 and this is minus 1.5 square, that is this is 2.25, so it comes 14.75. And third central moment, that is mu3 equal to this mu3 dash minus 3 mu1 dash mu2 dash plus 2 mu1 dash q. And I hope that you will you already learned this formula. So after putting values of mu3 dash, that is minus 30 and minus 3 mu1 dash mu2 dash. So mu1 dash is minus, so it comes plus, and 3 into that is 4.5 and 4.5 into mu2 dash that is 17. So this is minus 85, that is 5 and 8 and 17, 52. So it will be 60. This is here 60. 4.5, 60 and 0.5 and 2 mu3 dash q, 2 mu1 dash q, this is. So this is minus again q of is negative, this is minus, so plus, and 3 into 1.5 q. After calculating we get this is 39.75. Similarly, after putting values of mu1, mu4 dash, mu1 dash, all these which are given, after putting these values we calculate, it comes 142.31 approximately. So these are the central moment. First, this is always 0. Second central moment equal to 14.75. Third is 39.75, and fourth central moment is this. Right? Sorry. It is also asked mean. So there is also one formula, mu1 dash equal to mean minus A. So this implies mean equal to mu1 dash plus A. Mu1 dash is minus 1.5, minus 1.5, this is 4, so it comes 2.5 mean. And it is also given, as in case of theory, standard deviation. We know that variance equal to second central moment equal to variance of the distribution. It is clear. That is variance equal to mu2 second. Therefore, standard deviation equal to under root mu2, and it comes under root 17. That is 4.0 something approximately. This is standard deviation. Since second central moment is equal to variance, and we know that variance equal to standard deviation square. So standard deviation will be under root mu2. Okay. Variance equal to standard deviation का square. So standard deviation is under root mu. Okay. And next, beta 1 and beta 2, these are Pearson's coefficient. So we know that beta 1 equal to, we have beta 1 equal to mu3 square upon mu2 cube. mu3 square, third 39.75 whole cube square upon second 14.75 cube. Okay. After simplifying, we get, it comes 0.4924. 0.4924. And similarly, this is beta 1 and beta 2 equal to mu4 upon mu2 square. mu4, this is 142.31 upon mu2 square, that is 14.75 square. After simplifying, 14.75 squaring, so we get, it is 0.6541. 0.6541. It is. So these are Pearson's coefficient. So if moments about any points are given, how to find central moment? So see this calculation or process, find central moment and mean, standard deviation, beta 1, beta 2. Now curtices. About curtices, we have discussed that if beta 1 is the measure of the curtices, if beta 1, so beta 1 is here 0.4924. So it is clear that if since beta 1 is less than 3, therefore curtices is platykurtic. That is nature of curtices. Curtices means property of distribution of flatness and peakness. So this is the platykurtic. This is the nature or type of the curtices. Okay. So this is our first problem, and there some distribution is given, and also asked moments. So there is direct formula to find central moment or moment about any given point. Okay, and next problem is based on skewness, that is find the Pearson's coefficient of the skewness for the following distribution. This distribution, it is clear to everybody that it is a group distribution, group frequency distribution. Okay, and we have to determine Pearson's coefficient of skewness. So by formula we know that coefficient of skewness, that is called Pearson's coefficient of skewness. This is Y formula, mean minus mod upon standard deviation. Upon standard deviation. So it is clear that first we need mean, mod and standard deviation. Then by using this formula, coefficient of skewness can be found. Okay. So to find mean and mod is standard deviation from the given data. So since we have to determine both things, mean and standard, we use shortcut formula for, and this is group distribution. So we find step deviation. So for which we have first mid value. This is 2.5, 7.5 and 12.5, 17.5, 22.5 and 27.5, 32.5, 37.5. These are mid values. If we take, suppose this is the assume mean A. So step deviation U equal to x minus A upon h. So which is in our problem x minus A for 22.5 upon h for class interval. This is 5. So 2.5 for each value. This is minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. And after that, we have to determine FU. This is minus 4. So multiplied by the respective frequencies, corresponding frequencies. Minus 8. This is minus 15, minus 14, minus 13. This is 0, 16, 16 and 9. Similarly, we have to determine FU square, since it is used in to calculate standard deviation. FU square. So again multiplied by U in this. So this is 32 and 45, 28, 13, 0, 16, 32, 27. Okay. And now shortcut formula for mean is mean equal to assume mean plus summation FU upon capital N into H. So capital N means sum of the frequencies, sigma F. It is 7, 14 and 27 and 48, and this is 64 and 72 and 75. N and sigma FU equal to negative first minus 23 and minus 23 and minus 36 and minus 49. Okay, minus 49 and this is 32 and 41 and minus 8. This is So after putting value A, that is 22.5 plus sigma, that is minus 8 upon 75 into H, that is 5. So 22.5, and this is minus 15, and 8 upon 15. So it comes 22.5 minus 0.5 and 0.5 again, approximately this is. So it comes 5 and 9, 21. It comes. This is the mean, okay, by shortcut formula. And also need standard deviation. So it is noted inside, mean is equal to 21.95, that is approximately 22 p and 22 approximately. Okay, and next thing is mod. So mean is known, and now mod equal to, this is mod is this is, since group distribution, then by to find mod, we find model class, and model class is the which has greatest frequency, which is 21. So this is the model class 20 to 25, and this is formula to find mod is equal to L plus F minus F1 upon 2F minus F minus 1 minus F1, okay, into H. F, L is the lower, L is here 20, and F the frequency of this 21, and F1 is the frequency of succeeding class, F1 is here 16, and F of minus 1, this is preceding class, so F minus 1 equal to 30. And after putting these values, 20 plus F, that is 21 minus 16 upon 2F 42 minus 13 minus 16 whole into 5. So it comes 21 and 23 point something 05 approximately. So it comes, and now standard deviation. Standard deviation, so we note here also mod 23.05, and standard deviation is there is formula to calculate standard deviation under root sigma fu square upon n minus sigma fu upon n whole square. So sigma fu is clear. Now sigma fu square, all are positive. Sigma fu square 7, 15 and 18, and this is 24, 26 and 33. 6, 10, 12, 13, 14, 17 and 19. 193. Okay. And after putting these values in the formula, sigma fu square 193 upon n 75 minus sigma fu, that is minus 8 upon n 75 whole square, and calculated it. So we get, this is pause करना. So it comes 7.99 approximately 8. Now putting these values, mean, mode and standard deviation, it will take 9. So if we put value of standard deviation, and in this formula mean, so this is coefficient of skewness equal to mean, that is 22 approximately, minus 23.08 and upon 8, sorry, this is 8. So it comes approximately, after calculating, minus 0.148. Okay, minus 0.14. This is the coefficient of skewness, and particularly it is called Pearson. Similarly, there is Bowley's. According to Bowley's, we have to determine coefficient of skewness, in which we use quartiles, which are already discussed in the preceding problem. So we can also find coefficient of skewness by Bowley's, and this is the Carl Pearson's. Okay, so fine.